Welcome to the Lionheart Academy. My name is Richard Tai. Today is our lesson number 9 for trigonometry. We are continuing to talk about the functions of acute angles. So last lesson we have discussed the definition of sine, cosine, and tangent, and secant, cosecant, cotangent. So let's just go ahead and do another quick review. Okay. Alright, so let me go ahead and use this. Now remember, when we label our angles A, B, C, we always want angle C to be our right angle in the right triangle. Okay, and angle A and angle B would be our acute angle. So then this would be opposite side for angle A, this would be opposite side for angle B, opposite leg, opposite legs, and this would be the hypotenuse for the triangle ABC here. So the definition of sine again is of any acute angle in this case would be the opposite leg divided by the hypotenuse. Okay, and cosine of angle A would be the adjacent leg would be B divided by the hypotenuse, and tangent of the angle A would be opposite leg over the adjacent leg, which is a B. And secant of angle A would be the hypotenuse divided by the adjacent leg. Cosecant of angle A would be the hypotenuse divided by the opposite leg, and cotangent of the angle A would be the adjacent leg divided by the opposite leg. So, as you can see, the positions will change if you change the different angle. The definition will definitely change. I mean, the answer will change, but the definition will remains the same. And last time I did mention acronym called SOHCAHTOA, but I haven't had a chance to really talk about that. What this means is S stands for sine, opposite leg over hypotenuse, so SOH. Cosine, cosine is adjacent leg over hypotenuse. Okay, and tangents, TOA is tangent is opposite leg over adjacent leg. How do I determine opposite leg again? Opposite is always on the other side of the angle. It's not part of the angle. You see, side B and side C are part of angle A, but side A is not part of angle A. So that's why it's called the opposite leg. And this is the adjacent leg because there are two legs there are two sides, two adjacent sides to angle A. Side B and side C both are adjacent to angle A, but only B is adjacent leg. This is a leg. This is a leg. And again, what was a leg? A leg is the two sides of the right angle, and hypotenuse is the opposite side of the right angle. Okay, hypotenuse is the opposite right angle. Okay, so hopefully that will help you quickly review this. Now today, first thing we would like to talk about today is does the sine value, cosine value, tangent value, does the trig function value of angle A depends on which triangle it is? Well, I'm going to show you it does not depend on the triangle. It's independent of triangles. Okay. Now, why is that? Okay. So let me go ahead and talk about that. So the trig function value does not depend on a particular triangle. So we're going to do a little proof here for you guys to show you why is that true. So let's say we have a little right triangle here, and then we have, hold on, a triangle that has the same angles. Okay, so let's say this is angle C, this is angle A, and this is angle B. Okay, triangle ABC. Now this is angle C prime, this is angle A prime, and this is angle B prime. So those two triangles, let them be the same triangles. Okay, no, I'm sorry, not the same triangle. They are obviously not the same triangle, but let them have the same angles. Okay, so let triangle ABC and triangle A prime, B prime, C prime be two triangles, right, that have the same angle measurements, where angle A is equal to angle A prime. Okay, so the measurement of angle A and the measurement angle A prime are the same, and measurement angle B, well, actually I just need to tell you that angle A is equal to A prime. If angle A is equal to A prime, C is definitely equal to C prime, so B has to be equal to B prime. Why is that? Well, because remember, angle A plus angle B is equal to how many degrees? 90 degrees. That's right, it's 90 degrees. So if angle A and angle A prime, they're the same, angle B and B prime must be the same, because B is 90 minus A, but A and A prime are the same, so B prime must be equal to 90 minus A prime and 90 minus A. They are the same. So angle B and angle B prime must be the same. Alright, so now if all three angles are the same, then the two triangles are similar. Then triangle ABC and triangle A prime, B prime, and C prime are similar. I'm not sure if how much you remember from your geometry lessons. What does it mean to have similar triangles? When we say two triangles are similar, we're talking about that they don't just have the same angles measurement, they also have proportional size. They have proportional size. That means the ratio of their size are proportional. So let's say this is side A, this is side B, and this is side C here, and this is side A prime, and this is side B prime, and side C prime. Okay, so of course you can see side A prime, they are not the same. Side B and side B prime, they are not the same. Side C and side C prime, they are not the same. However, we know the two triangles are proportional, so A over A prime should be equal to B over B prime, and should be equal to C over C prime. So their ratio should be the same. So basically, triangle A prime, B prime, C prime is a larger version of triangle ABC. They have the same angles, they just don't have the same size. Their size are a different size. All right, so let's take a look at this. So because let's base on this equation here. If you can take a look at this equation, so that means A over A prime should be equal to C over C prime, right? So this is a proportion, and this is a proportion that we can cross multiply with and then divide. So if I go ahead, cross multiply, exchange this place, this two, this means that A over C is equal to A prime over C prime. So what is A over C though? Well, A over C, that happens to be sine of angle A, right? Sine of angle A is the opposite leg over the hypotenuse, which is A over C. And what about sine of A prime? Sine of angle A prime is equal to angle sine A prime over C prime. But A prime and C prime, A over C, and then A prime over C prime, they are the same. So we prove that sine angle A is equal to sine angle A prime, as long as they are the same. Angle A and angle A prime are the same measure. So that means trigonometry functions, trig functions, they are functions of the angle. And so we don't need to worry about the triangle per se, but we're showing you that sine of, let's say it's sine of 35 degrees. If angle A is 35 degrees, and then this angle A prime is 35 degrees, then doesn't matter what kind of triangles they are in, they would have the same value for their sine, cosine, and tangent, and all those measurements would be the same. Okay. So this is a very important fact that you want to keep in your mind with. So you don't have to worry too much about the triangles. I know we start with the triangle. We associate each of the sine, cosine, tangent function with the right triangle. But they are not limited to that, because the triangles eventually are just a tool to help us get those ratios. But trig functions are functions of the angle. They are independent of the triangles, the particular triangles. Okay. And because trig functions also just measures a ratio, they're just measuring a ratio of sides, so the angles, the particular side doesn't really matter in that case. Okay, and so I've shown you that we can actually do this for every function, but I think that won't be necessary for now. All right. So now let's take a look at some. I just want to mention in passing some of the less common functions of angles. So we have talked about the common ones: sine, cosine, tangent, secant, cosecant, cotangent. But there are some less common ones that you may run into in the future. But I just want to show them to you, okay, to give you a little bit of idea. Okay, they are more useful in engineering, advanced geometry, and other advanced topics. One is called the verse sine. Verse sine is called VERS, verse A. Verse sine A is equal to 1 minus cosine A. So these functions are not functions of ratios. They're functions of the angle, but they don't return you ratios. They return you relationship between sine and cosine. So we have verse sine, we have coverse sine. The coverse sine CVS is equal to 1 minus sine A. And later on, we're going to come back and revisit them on the graph. When we get to the next section, when we talk about unit circles, you will be able to see them visually. Because right now they're just words to you, I know, but we will be able to see them visually. So this is half verse sine of A. So it's half of verse sine of A, 1 minus cosine of A. That's very simple, eh? It's just one half of the verse sine. So it's called half verse sine. And subverse sine, subversed, VERSED, subverse of the sine. So it's called subverse sine, SUV A equal to 1 plus cosine A. Okay, that all those things can be represented graphically. Okay, and then last one we're going to talk about, there are actually a little more external. Okay, external secant. External secant actually is a very graphically is very intuitive. If you see it, you should be able to understand it. If you know secant and tangent lines back from trigonometry days, right? When you do the circles, you have external, you have tangent line and secant line. Part of tangent is part of the secant is external. Part of the secant is internal. This is the external secant. That's the part outside the circle. So it's called external secant, which is secant A minus 1. Anyway, so just want to show you that there are other functions that exist, and then we may not go through them. We may not talk about them again, but we probably want to show them again on the graph. And just to give you guys a good idea of what they are. Alright, so there's another topic that we want to go ahead and talk about before we go. Okay, now, so what does it mean? The question is, what does it mean if sine of angle A is equal to 2/3? What does that mean? Well, we know sine of the angle A is defined as what? Remember SOHCAHTOA, SOH? So it's the opposite leg over hypotenuse. So if I say sine of angle A is equal to 2/3, that means this can be represented graphically using the right triangle, okay? Using a right triangle, and if we construct a right triangle, we can actually construct right triangle with an angle A. Let's call this angle A right here. So if angle A is here, which side is the opposite leg? Well, it's over here, right? And then which side is the hypotenuse? Well, it's over here. So this suggests us that the ratio between the opposite leg and the hypotenuse is 2:3. So I can label the opposite leg 2 or 2 units, and then the hypotenuse 3 units. So this is the triangle that will give us an angle A that represents this situation. Sine A is 2/3. Okay, so knowing how to convert this and then to see this visually as a triangle in such a situation is going to be very useful in later on down the road in our course. So now let me show you another one. Let's say, what about cosine A is equal to 6/7? Well, if cosine A of an angle A is 6/7, I can draw another triangle. Okay. Now, right now I'm not drawing anything proportionally, but I'm just labeling this triangle. I'm trying to label the sides in the same correct proportion. The proportion of this adjacent side over, remember, so katoa, CAH, cot. So cosine is adjacent leg over hypotenuse. So the adjacent leg should be equal to 6, and the hypotenuse should be equal to 7. Well, this is not necessarily true. However, this is one simple representation of this equation, this angle A. So cosine A, if we say cosine A is 6/7, is 6/7, that means side A, angle cosine of A. If I represent this using a right triangle, the adjacent side should be equal to 6, or the multiple of 6, and the hypotenuse should be equal to 7, or the multiples of 7. Okay, let's try another one. What if tangent A is equal to 0.6? What does 0.6 mean? What does 0.6 mean? Well, 0.6 is decimal, right? It's a decimal. Okay, but 0.6, if you go ahead and express that in fractions, would be 6/10, right? Or if you reduce that fraction, it would be 6 divided by 2 is 3, 10 divided by 2 is 5, it would be 3/5. So that's the reduced version of this fraction, is 3/5. So that means if I put angle A here, and this is the right angle, okay, and so it's tangent. Now, what is tangent? Tangent is the opposite over adjacent, right? Opposite leg over adjacent leg, TOA, T-O-A. Tangent is opposite leg over adjacent leg. So it's opposite leg, you have a ratio of 3 in concordance to the adjacent leg will be there in comparison to the adjacent leg should be a ratio of 5. So this angle would be 3. This triangle will represent this angle A. And so one thing is, if you construct this correctly using a compass or a straight edge, and then using a ruler, you measure 3 units, 5 units, you construct the perpendicular lines and construct 3 units here, 5 units here, and then construct a triangle, and you can measure this angle A and find out what that angle A is using a protractor. So this is a very interesting way this is connecting the tangent of a function or sine of a function or the secant of a function to a graphical representation, and this graphical representation will be very, very useful down the road. Alright, let's just do one more before we go. Okay, so let's try this. Let's try secant angle A is equal to, let me go ahead and do this. Let's do 1.3. Okay. Well, what does that mean? Secant of A is equal to 1.3. Well, first of all, think about what is the definition of secant. Think about what is the definition of secant. That is the thing that you have to think about first. Well, the definition of secant means what? The definition of secant is opposite over what? Opposite, no, I'm sorry, it's hypotenuse over adjacent. Hypotenuse over adjacent. So the key right now is we want to go ahead and write 1.3 using a ratio. Well, 1.3, how do I write 1.3 as a ratio? It's 1.3 over 1, or 13 divided by 10. Okay, 13 divided by 10. Now, can we simplify anything else? No, we can't simplify anything else. So let's do 13 divided by 10. So let's put angle A here. So let's think about which side should be our hypotenuse. Well, that's the side that's opposite to the right angle. Opposite to the right angle. So that side should be 13. And adjacent is the leg that's connected to the angle A, which is 10. So that's adjacent leg. Adjacent leg. That's the side connected to the angle A. And so this represents this triangle, simple triangle, will represent the angle A, secant A. That's 13. That's equal to 1.3. 1.3. All right. So this is it for our lesson today. Next lesson, we will continue to talk about functions of acute angles. We have several other topics that we need to cover. So hopefully, if you have any questions, any comments, please do leave your questions and comments down in the comment section below, and then I'll try to answer them as much as possible. Also, I look forward to hear from your feedbacks to see what you think about lessons, and so I can make adjustments accordingly, and then, or if there are any topics that you would like me to cover, we can go ahead and do that as well. And so, well, thank you for joining our lesson today. Hopefully we can see you next time and continue our lessons in trigonometry. All right, thank you.